You know when you flip a switch, the lights just poof, come on. It feels so simple, right? Instant. But behind that one little switch is, no joke, one of the most complex machines humanity has ever built, the energy grid. So today, we're going to take a journey, a deep dive, to see how this whole thing is actually put together.
No, seriously, just take a second and think about it. What does it really take to power an entire city? It's not just a couple of wires strung on poles. We're talking about a massive, interconnected web of giant power plants, transmission lines that stretch for hundreds of miles, and super complex control centers. All of it has to work together perfectly all the time. So the big question is, how on earth does something that huge even get built?
Well, to figure that out, let's look at a company that actually does this stuff for a living. We're talking about global players like WHT Energy. These are the folks who specialize in building these huge, utility-scale energy systems right from scratch. Their work gives us a perfect window into how this whole massive puzzle comes together.
All right, let's get into the nitty-gritty, because these numbers really tell a story. We're talking over 400 projects all over the world, and the scale? It's just mind-boggling. A single project can be up to 1.4 gigawatts. I mean, what does that even mean? Well, that's enough juice to power over 1 million homes from just one project. And you don't do this alone. They partner with the absolute biggest names in the business. We're talking GE, Siemens, Mitsubishi, and they manage the whole shebang from start to finish.
Okay, so our journey's got to start at the source, right? And that means the power plants. This is where the electricity is actually born. Whether it's from burning coal, oil, or natural gas, this is ground zero.
Now hang on a second. Before we get any deeper, you're going to see this acronym pop up, EPC. It stands for Engineering, Procurement, and Construction. But what you really need to know is that it's what's called a turnkey solution. Think of it like this. One company gets the keys to the whole project. They handle everything, from the first drawing on a napkin all the way to flipping the big switch to turn it on. It's how you make sure a project this ridiculously complex actually gets done right.
So here's what that looks like in the real world. You've got a project like the Izdemir coal-fired plant in Türkiye. That's a full turnkey EPC job. But sometimes a company just handles a specific piece of the puzzle. See these oil-fired plants in Sudan? The scope there was BOP EPC. BOP. That stands for Balance of Plant. Basically, it's all the other critical stuff. The cooling systems, the wiring, the pumps, everything that the main power-generating turbines need to actually, run.
And it's not just coal and oil. There's a ton of expertise in natural gas, too. I mean, look at the Bursa plant in Turkey. That thing's a monster. We're talking over 1,400 megawatts. But what's super interesting to me here is the obsession with uptime. It's not enough to be powerful. You have to be reliable. And they do that by integrating these really advanced control systems. You might hear them called SCADA systems. Just think of it as the plant's digital brain, constantly monitoring every little thing in real time. It's what makes these plants not just powerful, but rock-solid reliable.
But hey, it's not all about fossil fuels, right? The grid is changing, it's diversifying, and a huge part of that change is learning how to harness the incredible power of nature itself. First up, water.
And when you look at these big hydropower projects, you see the exact same ideas in play. That turnkey EPC model we talked about, it's absolutely crucial here. Why? Because these projects are two giant challenges in one. You've got the massive civil engineering of building the dam itself, and you've got all the super complex electrical and mechanical work for the turbines. So whether it's a huge dam or a smaller plant, having that single integrated approach is the only way to manage it all. All right, so we've made a whole lot of electricity. Awesome. But that power is totally useless if it's just stuck at the power plant, right? It has to get to our homes, our schools, our businesses. And that brings us to the second and just as critical part of this journey, the grid itself, the delivery system.
The best way to think about transmission lines is like the superhighways for electricity. They are the absolute backbone of the whole system. They're what carries all that power over huge distances from the plants, which are often way out in the middle of nowhere, all the way to the cities and factories that are hungry for it.
And when I say huge amounts of power, I am not kidding. Check this out, 400 kilovolts. To give you some perspective, the outlet in your wall is probably what, 120 or 240 volts? This is thousands of times more powerful. You need that kind of muscle to push electricity across vast distances without it just fizzling out.
And it needs all that power to travel more than 91 kilometers on just this one line. Building a single power line with that much voltage for that long, that is a monumental feat of engineering. Think about it.
crossing mountains, valleys, rivers. It requires absolute, painstaking precision.
Yeah, this is so much more than just sticking some towers in the ground. The whole process is incredibly meticulous. First, you have to survey every inch of the land. Then comes the heavy lifting, massive civil works for the foundations. Only then can you erect the towers. After that, they have to string these incredibly heavy cables, sometimes for hundreds of kilometers. And even then, it's not over. It's followed by tons of testing before the line can finally be commissioned and, switched on.
Of course, the grid isn't just a bunch of long, straight lines. It needs hubs, interchanges, traffic circles, if you will. That's where substations come in. They're like the traffic cops of the grid, stepping the voltage up or down and telling the power where to go. And what do you do in a super dense city like Istanbul? You can't just string these giant power lines over buildings. So the answer is to go underground. They lay these high voltage cables right under the city streets, which is, as you can imagine, a hugely complex job. You're trying to navigate a maze of subway tunnels, water pipes, and everything else that's already down there.
So let's step back for a second. We've got power plants, we've got transmission lines, and we've got substations. How does one company possibly manage to build all these different, super specialized, highly complex pieces of the puzzle and then make them all work together seamlessly? Well, that's where we get to the integrated advantage.
It really boils down to a core philosophy that you see across the whole industry. It's about having a big picture view. It's about understanding the entire system, from the moment the power is made all the way to the plug in your wall, not just focusing on building one little piece in a vacuum.
And here's the secret sauce. Having one single accountable partner for the whole project, that integrated EPC model again, is a massive advantage. It lets you use what's called a grid-first engineering approach. Now, what does that mean? Instead of building a shiny new power plant and then scratching your head wondering how to connect it, you build the transmission lines at the same time as the plant itself. And that, right there, dramatically speeds up how quickly you can get that new power flowing to the people who need it.
But let's be real, the world's energy grid isn't all brand new, cutting-edge stuff. A huge part of keeping the lights on is maintaining and upgrading the older plants, the ones that have been the reliable workhorses of the system for decades. And this is where something called life cycle services comes into play. Just look at the scale of these rehab projects on existing coal plants. We are talking about upgrading and boosting the efficiency of absolutely giant facilities, like this one with almost 1,000 megawatts of capacity. It really shows a commitment to the entire life of an energy asset, not just building it and walking away.
So, from the power plant all the way to the plug in your wall, we've seen a little bit of how the modern energy grid gets built. It's a breathtakingly complex dance of generation, transmission, and control. But here's the thing, this system is never static, it's always evolving. And that leaves us with one big question to think about. As all of us demand more clean energy and a more reliable, resilient grid, what incredible new feats of engineering will it take to build the grid of tomorrow?